continuous talk about the things, but I'll go over specific homework questions. A lot of you guys didn't understand how to do certain questions, especially I think question 33. Um, so we're gonna talk about question 33, and we're gonna talk about definition of alternative derivative. Um, so here that question 33, I forgot what's question 33, was x squared, and they say it's what? Negative y 2x plus 1 equal to 0, right? They say you have to be parallel to this. So you want to sum equation tangent line somewhere the slope of this x squared graph. So the slope of this x squared graph. So I'm gonna draw the x squared graph here. So that's gonna be like something like this. But it's a parallel to this this one. We're gonna solve for y. So it's y equal to 2x plus 1. So it's gonna be 2x plus 1. It's gonna be right here. It's gonna be parallel to this one. So the tangent line slope is probably more likely to be on the right hand side of the graph rather than left hand side of the graph, because on the right hand side you're gonna have some type of positive slope. So it turns out that if I take a derivative here, and I'm not gonna do that fully, but I did it on the notes. So it'll be x plus h squared minus x squared over h. And then somehow you finish taking derivative, and that's equal to 2x. If you did all that work, it's on your notes, right? We did that. So 2x. So what you're gonna do is you're gonna 2x. This is a slope at any point. So slope at any points. So then we can set it equal to the slope is equal to 2 because you want a parallel. So that means x has to be 1. Now x equal to 1 is going to have something like this, a tangent line hopefully like this. The slope is going to be roughly exactly like a green line. But we want to find out the equation of this particular line. We must know what this point is. Here we know it's 1, 1 because I draw the graph correctly. But if I don't know the graph correctly, I'm going to have to plug in 1 into the f of x function. So it'll be 1 squared, that's equal to 1. So that means 1 comma 1 is going to be your coordinates. So then all we got to do is y minus y1. So it's 1 equal to m times x minus x1. Now what happened to slope right there? It's going to be what? 2. And then just plug in 2. So 2 times x minus 1, y minus 1. So this is 1, sorry. So this is your final answer. And you're going to find equation of that. This is 1.
What did that say? The slope of?
Slope at any points. Yeah. Yep.
How did you get 2x equals to 2?
2x equal to 2 because they say at somewhere along the line they're going to be parallel to the other side. Parallel with the line it's giving. Now, if we find out the parallel slope of that line, that slope is 2. So you want to set the 2x, which is the derivative at any point, is equal to 2 because you want them to be parallel. Okay, so that is the first one. This is question 33. I didn't assign the rest of them. It has 34, 35, 36, 37, 38. But as I assigned an even problem today, so you guys are going to have some situation to see. Now, with this type of question, I didn't go over and I still assigned to you. Obviously, some student figure out. So the goal is always to figure out the questions that I trying to challenge you more of. So this is the question I didn't teach you, but you have enough basic background knowledge to solve the problem. As a student, you want to try to look for those problems, you try to solve it. Now, if there is a chance that you cannot solve it, yeah, that's so be it, but you have to try. You cannot just say, oh, I didn't even get there. You have to try, get there, and try to finish those problems. Unfortunately, those problems are difficult. The question before that, I don't know what's the question before that, was x plus 4 over x, right? Is that right? Is that right? And they want to add -4, -5. Is that right? Equation tangent line. You guys did that one? I see Eli did it on the front, and he got a derivative of x squared minus 4 over x squared, which is correct answer. Now, for those of you guys don't know how to do it, you have to apply the definition of derivative, which is limits as h approach 0 of x plus h, f over x plus h minus f over x over h. Now with here, I'm gonna write down another line, h approach 0. This one's gonna be x plus h, plug in for x, minus 4 over x minus plus h, minus x plus 4 over x, and then all over h. Now, this first step, you should know what to do. Now, if you don't know what to do from here, I understand, but it's just algebra. So h approach 0. This one's going to be x plus h minus 4 over x plus h minus x minus 4 over x. Always distribute. Now you're going to see something that is very easy to cancel out very beginning, so you don't have to do a whole lot of work if you cancel out very beginning. Now you're left with the h minus 4 over x plus h minus 4 over x. I leave some space because I know I need to have a combined order fractions. So I need to multiply this by x plus h over x plus h. I need to multiply this by, I believe, x. And I need to multiply this top and bottom by x times x plus h. Sorry, let me rewrite that. X times x plus h over x times x plus h. Now everything have a same denominator, so I can x plus h here, and this is hx times x plus h minus 4x minus 4x minus 4h times 1 over h when limit h approach 0. Now you see here, there's something I can cancel. Now I can also, I want to get rid of this h. This h is the, like, how do I say it? Thorn in my eye, pretty much. Right? So because when h approach 0, the whole thing go to undefined. So then you want to take out h from the top. So what you can do is you can factor out h. So this one is going to be x times x plus h. If I factor out h, that's going to just left with that. And minus 4 over x times x plus h. And this is 1 over h. Finally, this can cancel. And then now h has to approach 0. And I'm glad that Bennett says, I didn't know what to do the last step. You all gotta do is plug in h is equal to 0. So if h is equal to 0, this is gonna go to 0, this is gonna go to 0. So it'll be x squared minus 4 over x squared. So that is prime of x. And then if you plug in -4, so it's gonna be -4 squared minus 4 over -4 squared. That's equal to 30 over 4. And it's going to be y minus 5 equal to 3 over 4 times x. I think it's plus 5, plus 4. I think it's that right? Is that right? 4, 5, yeah. So that would be the equation tangent line. Equation normal line is going to be 4 over -3, so just so you know. So yeah. Phoenicia, the question? No? Yeah.
How did you cancel out the -4x and the other -4x?
Wait a second. This should be plus, right? This should be plus here. And then this is plus. Sorry about that.
Where does the plus start?
Because this original equation is 4x plus 4 over x. So this should be plus here. Remember, this is a x 4 over x. So this is a plus. So I forgot that sign. You're right. So that 4x and -4x would have canceled out. Thanks for catching that. Questions?
Where did the x squared come
Where'd you get x squared? Those x should multiply together. And by the way, Brendan, that's not homework. You're trying to trick me. That's not very appreciative. Because the h is going to go to 0. If h goes to 0, it'll be x times x. H is going to approach 0, so I'm going to substitute h is 0 here. So this is 0, so it'll be x times x. This will be x squared.
The one above that.
Above that same thing, h is going to approach 0. This is going to be x squared minus 4.
You remove the original the denominator to the side where you get the 1 over h.
Yeah, because it's divided by h, it's same thing as times 1 over h. So therefore, h can cancel off when after I factor out h in the top.
So did you like? So I'm having trouble understanding when you say you substitute h as 0 and then like that's all.
Because when limit h approach 0, that means all the h here need to go into 0. But I'm going to have to cancel this h first before I do that, because otherwise it'll be 0 over 0.
Not thinking about the x plus h going into x squared. I'm thinking about like the original denominator.
So do you understand now, or are you still confused?
I guess
Are you sure?
it's like you have the leftover 1 over x plus h as on top. Then you just substitute that into the denominator.
So this is what I have left over. And this h gonna cancel out. Is that okay? So whatever h here is gonna be 0. So this will left with the x squared, because x plus 0 is just x. So that's how you get x squared here. Now this is minus 4, is nothing there, just minus 4. On the bottom part, h is gonna go to 0, so it's gonna be left with the x times x, so it'll be x squared.
Wait, and you're plugging in the -4.
Wait, is that plus 4 or negative 4? Sorry, this is a plus 4. Wait, is that plus 4 or negative 4? It's plus 4? Oh, this is a plus 4?
What question is it?
Is it plus 4 here? Okay, I'm so sorry. Yeah, I think that's what it's causing. I'm confused.
No, it's negative.
Negative?
The coordinate they give you at the start.
But it should be plus 4 though.
Negative.
Oh, it's minus 4. Yeah, it's minus 4h. Yeah, this is correct. All right, so you're gonna have more practice question, and you're gonna have quiz about definition of derivative, but we're gonna talk about definition of alternative to derivative. Alternative is this. So this one is gonna be definition of derivative. So definition of derivative is gonna be limits as h approach 0 of f of x plus h minus f of x over h. We already do this a lot of time throughout yesterday. And this is f prime of x. Now, what if I just replace that f prime of a? What will happen? Well, that means everywhere you have x, right? If h approach 0 of f something parenthesis plus h minus f of something over h. So remember, I just replaced this part with a. You can actually find derivative at a specific point. So this is a derivative. This is derivative at or slope, right, interchangeable at any giving x, any giving x. Now the bottom one is, this one is a derivative at x equal to a. So that means whatever the constant is. So take a derivative constant at 2, then I'm going to plug in 2. So this is more specific x value. The other one is could be anywhere, which is nice. So I'm going to give you a definition of alternative derivative. So derivative here. Definition of alternative derivative. Basically, rough the same thing with limits x approach to c. Instead of h approach 0, it's going to be x approach c. F of x minus f of c over x minus c is equal to f prime of c. That is f prime of c. So this is something that we're going to be using today. But basically, this is where the origin. You have some graph like this, and this is going to be x comma f of x. Is that okay? And this is some point here is going to be c comma f of c. So same idea is, if you find equation of secant line, it's going to be f of x minus f of c over x minus c. And hopefully that c is going to go into here to find out this equation tangent line. C is changing, approaching 0. So be limits as x approach to c rather than h approach 0, because there's no h here. We just want to say that c is approaching to x. Eventually you're going to find the slope right here if c becomes x. So that's equal to, sorry, that's equal to f prime of c. Okay, this is equal to f prime of c. So that is gonna be the binding from, this is c. Imagine this c is no longer x, it's going toward the x. So the, or sorry, it should be the other way around. X go toward the x, the slope should be this line rather than that line. Okay, so let's erase this one. I mark it wrong. So if x approach c, that's going to find out the slope at that giving point. That giving point is the c. Now I'm going to say is I'm going to name a function. Let's just say this is f of x. I'll give you 3x to the third minus 5x squared. And I'm going to say f of prime of 2. So if I say I want to find out derivative at 2, I can use this idea. I can first, so I can use this one too, but I'm gonna prefer to use this one today. So be f prime of 2. Is that okay? Because I just replaced the c with 2. Is that okay? Is equal to limit x approach to what? 2. Not h approach 0, but it's x approach 2. Of f of x minus f of 2 over x minus 2. Is that okay? Now, obviously, if I plug in 2 on the bottom, it's going to be 0, and it's going to be does not exist. But that's not true, so we're going to limit x approach 2, and this is 3x cubed minus 5x squared. I need to figure out what the f2 is. I'm going to figure out on the side, so it'll be 3 times 2 to the third minus 5 times 2 squared. So 2 to the third is what? 8 times 3? 24, right? Minus 20. And that's equal to 4, I think. Is that right? It's minus 20. Why is plus 20?
Isn't like it off?
It should be, this 2 square is 4. 4 times negative 5 is negative 20. So this is minus 4. Is that okay? Is that right? Now this is a part that, because it's third degree and second degree, you cannot factor with a box. It doesn't work here. What you can do is, you can actually do a synthetic division that Jesus trying to teach Alan the other day. Thank you, Jesus.
You're welcome.
3, 95, but you must have a placeholder because there was no 0x here, and there's a minus 4. So I can drop the 3, 2. That's 3 times 2 is 6. That's 1. 1 times 2 is 2. This is 2. 2 times 2 is equal to 4. That's 0. So that is equal to, if you divide it by x minus 2, they'll actually end up to be 3x squared plus x plus 2. Is that okay? And I can plug in 2 there, so it'll be 3 times 2 squared plus 2 plus 2. It's 4 times 3 is 12 plus 2 plus 2. That's equal to 4. Oh, sorry, equal to 16. So the answer is 16. Wait, the answer is 16. Hold on, let me make sure. It's 9. $36. Yeah, 16. Yeah, that's right. Huh? Yeah, you can, but today I'm try to teach you use new formula because you gotta recognize the new formula today. So I'm gonna name a function and I say, hey, do you know how to take a derivative of this? Negative 2x cubed plus 5x squared when f prime of, I don't know, name a number. 5. 5 is kind of big. Let's do with 3. Yeah, f of x is negative 2x to the cube plus 5x squared, and we say f prime of 3. Now everything you have to do is that division because sometimes you can factor the top. If it's in quadratic, maybe something is factorable. The only time you have to do like that division is like x to the third degree, and it's not factorable. Sometimes it can be factorable. Yes.
So will the alternative derivative problems always be like cubed and then squared for the equation? Or is that just
No, I can give you anything. And just in this case, you have to use synthetic. But the other case, like if it was x squared, then probably more likely it's factorable. It's a factorable, then it's just really easy. And I just never show you synthetic divisions, and I thought I need to show you because some student did try to show each other. With Jesus trying to show after school. Which is fine, I think. Huh? In this case, you're not gonna get a remainder just because you with derivative is usually factorable. It should be a negative number. Your answer should be negative, right?
What?
Your homework's already posted. You can start off early. Brandon, make sure you show me your homework. Don't try to sneak
That's
on
the
me.
last time you ever.
Ah.
You can give me a 0.
Mm. You trying to be like the Jackie Chan and Chris Tucker, like a Shanghai Noon? Well, not Shanghai Noon. Rush Hour.
I watched one.
You know, like the Chris Tucker, he goes like FBI. He goes like FBI, and he put back the wallet. But it's actually not. It's like he was like a police, like LA police. But he was like FBI, and that's why he's like to do homework, Mr. Ye, and then it's flip back. Homework. Yeah.
Like walk up and ring out the doorbell. Well, it's just like right in the
Yeah. Oh yeah, I can.
I couldn't walk by this. Yeah,
What did Tyree Hill get arrested? And he got arrested for that? Oh, yeah.
What?
Do they have an answer?
In my book, yeah.
What'd you get for 66? 66 off the way. You have 5 seconds. One. I thought this was the point number.
Yeah, every question you have to do synthetic division. Sometimes you just factor it. And sometimes it's a third degree, then I will have to do synthetic division. You sick? Stay away. Back it off.
Remember when I coughed like the entire year? That's how I did.
Yes. Dude, you're allowed. Dude, it was so loud. 7 in the morning.
I don't know why. No, like. Why do you think that's you when you
Yeah. Okay.
You already went over the test, right? You already went over the test.
Yeah, I
But did you do well? You think you did good?
know what I need to do to get.
I probably need you to grade your own paper.
When do you think tests are gonna be graded?
Huh?
When do you think tests are gonna be graded?
Hopefully this afternoon, if enough people come here to help me. The point slope form is best, yes. Slope intercept form is just too much work.
I just got to like the thing. You want the thing X, and then I didn't do anything after that. But I know.
Yeah, if you say it's equation tension line, yes, you have to find them.
Okay, well, that's.
That's okay.
I know how to do it.
Today's homework, there's some repeated work questions, so that way you know what to
Okay.
do.
And, did you get the? Did you have the 10 points on the algebra test? You find the
I had to look at it later. I'm gonna have to time this period to do it, so I'll probably do it right now to look at it first. I don't know. I'm not sure. I think I already added, but I did add everybody who deserved to add, but I'll double check.
Okay, because I remember vividly that I got a 60.
Okay. No problem. Not going anywhere.